Welcome. Good morning or afternoon for those of you joining us from the East Coast. Thank you for joining today's webinar brought to you by Microsoft and Incycle Software. My name is Stephanie Long from Incycle and I will be moderating today's webinar. I want to let everyone know that this webinar will be recorded for future reference. If you have any questions throughout the presentation, please type them in the chat box and we'll do our best to respond either throughout the presentation or at the time reserved for the Q&A session at the end. Questions not addressed in this webinar will be answered in a follow-up email. Now I'd like to tell you a little bit about who we are. We've been around since 2002. We're a Gold ALM partner and also cloud partner. We're focused on TFS-related services, such as installation and migrations, release management, and agile tool training. From the Azure perspective, we also perform related services, such as infrastructure setup or application migrations. These are just a few examples, but we really cover the full ALM, DevOps, and Azure spectrum. We have consultants across Canada and the US, so we most likely have someone in your area. Now I'd like to tell you a little about our presenter, Gregory Shepard. Gregory is a senior Azure consultant at Incycle. He's a seasoned architect with a ton of experience developing and helping customers take advantage of the Azure platform. His expertise is in a broad spectrum of Azure, such as storage, mobile development, web applications development, etc. Over the next 45 minutes, Gregory will be discussing best practices on migrating your applications to Azure. Now I'll turn it over to my colleague, Gregory Shepard. So take it away, Gregory.
Thanks, Stephanie. I'd like to thank each of you for participating in this webinar. I'm certainly grateful for the opportunity to present application migration best practices. My objective today is to take you through a set of best practices for migrating applications. It obviously won't be the entire universe. It would take a download of, I think, of a gigabyte of content into your brain. But my objective today is to help you answer some of these questions, including should you use a cloud service or a website, or which is now called in Azure App Service, what Azure features drive code refactoring, how should I monitor and identify problems in my deployed application, and what 3 proven security measures show up in secure cloud applications. And by addressing these questions, I think we should be able to show you a number of best practices across a number of areas. So overall, I guess in the detail, our agenda is to talk about cloud service or app service, and specifically talk about refactoring for the cloud, and that's your application code. Talking about securing your application for the cloud. 4th is keeping your application available, and then we'll have time for question and answers. So cloud service or app service, let's get started. Cloud service or app service, in the end, there are a couple of things that you're trying to accomplish. One is to optimize cost, minimize complexity, and complexity comes in application development complexity and also in deployment complexity, and also to minimize your management workload, and that is the effort required to, again, to redeploy, to re-update, or to monitor what's going on with your application. Microsoft has renamed the Azure websites to App Service, and in doing so, they've really made this service a lot more easy to use and added what I might call some leverage features to make it a more powerful platform. Overall, between app service or cloud service, you get build, deploy, and scale with ease. With the app service, again, which used to be called Azure Websites, you can develop simple to complex scenarios, and you'll have streamlined management tools. And it's, I think, one important thing to note, the word websites, and I believe Microsoft renamed websites to app service, because when we think of websites, we often think of relatively simple static websites. But in fact, the app service will allow you to develop simple or very complex scenarios. And you can also build and deploy custom web applications, also non-web workloads in a task we'll call web jobs, which is called web jobs in Azure. You automatically get production and staging slots, which is a great feature for what you might call testing in production, or A/B testing, if you're making changes to an application. You're trying to get an idea of how your users are going to respond from one to another. In general, our guidance is that you should use the app service by default unless you believe there are some mitigating circumstances which would lead you to a cloud service. And the primary drivers for cloud service are complexity, effectively. You still get build, deploy, and scale with ease. You get the app service workloads, which are simple to complex web applications. You get, in addition, what's called web and worker roles, and that allows you effectively to, if you're familiar with the .NET framework lifecycle, you get a fairly similar ability to manage the lifecycle of the application using web and worker roles. Typically, you'll choose the cloud service when you need to control the virtual machine that the cloud service runs on, either by a requirement to RDP, which is a remote desktop into the virtual machine, or to install some kind of software on the virtual machine. You won't have those kinds of opportunities with websites or the app service. In addition, cloud service really works well when you have complex workloads that may be task-oriented, process-oriented, where, as you can see in this diagram, we have web role instances and worker role instances. And at the worker role instances, we see that, for example, we may have a cache or cache service, or we may have some kind of a workload that requires multiple instances to process a large workload, where you see in this particular graph, Azure queues are used as a messaging interface to allow the web role instances to do some work and then hand it off to a worker role. So this is an example of a more complex workload that's process-oriented, which is a great fit for a cloud service. The next area for best practice in migration really falls into the code area. And generally, when we talk to organizations or individuals about migrating applications, re-architecting or refactoring code is often a very important part of that discussion. And the primary reasons are, one is that there are a number of features in Azure that you might want to leverage in the future or even today, including messaging, cheap storage, fast data access, and asynchronous type operations. One of the first things that I recommend organizations do is to ensure that they've considered and are utilizing a best practice in authentication and authorization. A lot of times we like to homebrew our own approaches to authentication and authorization because this is the cloud and the world is moving more and more towards the cloud. You increase your threat surface, or the opportunity for things to go wrong, let's just say, when you use your own approaches that may not have been proven out over time, like some industry best practices. So I recommend that organizations choose and leverage Azure Active Directory access control. And what it really gives you is the ability to take authentication and authorization out of your code, because it actually comes in, we'll say the SDK, and allows you to focus more on your problem domain and ensure that this standards and compliant approach to authentication and authorization is used in your application. Out of the box, it supports a number of standards, Windows Live ID, federated support for Google, Yahoo, and Facebook logins, and the OData protocol. Active Azure Directory Access Control Service, I think, is a great way to refactor your authentication and authorization and ensure that you've selected a best practice and reduce your threat surface in your cloud application. Another approach is to consider Azure storage and to leverage Azure storage. In general, you can accomplish a number of things. One is to loosely couple components. In a graph or two ago, I showed you web and worker roles interfaced with a Azure message queue. This is a great pattern to use, again, for processes that are long-running, that require asynchronous or fire and forget type processes. And in general, when you consider an application that runs on a standard hosted service, you have access to the local file system, and you may store files in the local file system. Moving applications to the cloud, however, you have the consideration of multiple instances of your application running, and now being concerned with synchronizing files across various instances. So Azure Blob Storage, which is a service that allows you to store large objects, small objects, binary objects, images, recordings, etc., in a very cheap storage medium, allows you to move those kinds of assets away from local file services to the cloud and to a cloud service, which becomes more available to instances of your application that are running in the cloud. Another opportunity is to use table service, which is a NoSQL variant provided in Azure as a service. It's a non-relational database, and it provides extremely fast queries if the data is partitioned or effectively set up correctly. And a great use in refactoring here is for reference data that obviously doesn't have to be utilized in a relational schema like in SQL Server, but is referenced by your application, and again, you get fast queries and fast access, and you can move it away from a bottleneck, which could be SQL Server. The next pattern here is the use of external configuration store. So again, in Azure, you have the opportunity to have multiple instances of your cloud application running at a time. A bottleneck could be trying to maintain session state or some configuration files in one instance, and then you have multiple instances running, and now you're trying to synchronize, or you make a change in one instance, and now you have to synchronize those changes across instances. The approach to mitigate those kinds of concerns is to use an external configuration store. And effectively, that could be something like cloud storage, like I mentioned before, or a database like SQL Server, and even local cache or a a caching service becomes an external store when you consider static content as configuration content. So you get centralized application and configuration data. The content or the data is reachable by all instances of your application. You minimize your management workload because you're only making changes or moving content or data into one place. And this pattern is also used to keep web instances stateless, because the Azure environment provides you with multiple instances, and the multiple instances also serve as a mechanism to ensure that your application is available if one instance should go down. It's important that your applications are stateless, so that as a user's going through a particular scenario use case in one instance, if something were to occur on that instance, you don't want the user to get stuck with just that instance. If the configuration data or the data that they're accessing is, say, persisted to storage, a new instance could fire up, allowing the user to continue without worrying about where that data is. So this pattern makes a lot of sense, and it also helps you scale your applications. Using Azure Content Delivery Network for static content, this is a pattern that lots of organizations use, particularly applications that have lots of content and are globally dispersed. The Content Delivery Network is reachable by all instances again. It can also reduce your compute usage, which is effectively CPU, which translates into cost, because for example, you can request files from a storage service without actually, say, getting it from an instance. It can be globally distributed, centrally managed, and again, it helps to minimize your management workload because the static content is moved and managed from one place. And effectively, what you end up with is that you put links to files that are stored in, say, a storage service, and as you serve up pages, the links actually pull content from storage. So again, it minimizes the compute usage, and it ensures that centrally managed data is available by all instances that are deployed. Another great pattern, and an important pattern for cloud applications, is what's called retry for success, because of network latency and the dependency of distributed components within your application. So you could have a caching service, you could have SQL Server running, you could have web services running. The opportunity for something to go wrong is higher than when things are, say, either closer or all together in, say, your own data center. As a result, the opportunity for transient failures increases. So given this graph here, an application, say, makes a request to a hosted service, which may be one of your hosted services or someone else's, and that service call fails in its first attempt. Because you've refactored your code and it's now oriented for retry, the application tries a second time and it still fails. And fortunately, because your developer said, 3 times and you're out, was successful. So, to some degree, we'll say better a little later than never. But retry for success is a pattern that I'd say is a must-have in your applications, particularly when you look at database and service calls and overall user experience. The next issue here is securing your application for the cloud. And I'm going to reiterate again the idea of using Azure Active Directory services because, one, it's a true and tried practice. Microsoft understands Active Directory probably better than anyone else, and they've incorporated it into the cloud. And in fact, that same service set of services is used for a variety of Microsoft services, just to give you an idea of their scale, with Outlook 365, Outlook email, any number of the major Microsoft services today are using the same kind of authentication. And by incorporating it into your application, you get that same industrial capability, if you will. And so again, for emphasis, remove authentication and authorization from your code base, and use these tools that basically come in the SDK. They're all standards-based, and again, come out of the box supporting OData and Azure ACS. Secure communications are important, particularly if you have an on-premise data center connecting to your Azure cloud service or virtual network. It's important that you use an Azure VNet to connect cloud services, web apps, and databases. You want to make sure that if you are connecting from an on-premise to an Azure resources, that you're either using a VPN, which is a point-to-site or site-to-site, or ExpressRoute. And ExpressRoute is a great feature. It's effectively a private circuit that is provisioned by a service provider directly from your premise to the Azure data center. So it bypasses the public internet, and your traffic is about as secure as it can get. And it's a great tool for organizations that just want the highest level of security, or in cases where you have fiduciary responsibility for, say, healthcare data, or in a regulated environment where HIPAA, as an example, is a requirement, and you have to take greatest care possible to protect client data. In addition, you get the opportunity within the virtual network and within the cloud service to use Azure security groups to control traffic to and from the VNet. So you can secure communications, and it's really an important part of your consideration as you migrate your applications. Protecting data is also a key concept. You should be using SSL with sensitive data. You can have, and you do have the option to encrypt application data, and you should always encrypt configuration data like connection strings to databases. And you can consider, or should consider, encrypting SQL data in cases where that data is valuable or must be protected. So the key objective once you deploy an application is to keep it available, keep it running. There are a number of things that you can do, including using Azure Application Insights, which I'll chat about, and some techniques that you may already be using in more traditional type applications: logging, tracing, debugging, and diagnostics. However, some of these tools are specific to Azure, or there are SDKs available specifically for the Azure framework. And also code refactoring becomes another tool in ensuring that your application is available. Overall, when you look at scalability and availability go hand in hand. If you want to scale your application, or let's say if you want to make sure your application is most available, it must be able to scale. If workloads increase, then you obviously you may lose availability. So those two come hand in hand, and there are a number of things that we've chatted about, and some things that I will chat about that can help you improve scalability and ultimately availability. However, in general, the range of considerations for you are: one, instrumenting your code, using health monitoring tools, as you can scale bigger, better, and faster, and a number of those features are effectively built into the Azure framework and are available in the management portal. The app service makes scaling about as simple as it possibly could be, and includes the option to auto-scale based upon certain metrics, like CPU usage as an example. It's important that you script repeatable operational tasks. Automation is a great tool. Once you get it right, it allows you to repeat tasks over and over again. So deployment tasks, for example, can be scripted and repeated over and over again. And testing is also an important component of the availability, scalability equation. You need to know how your application is going to behave under load testing, so that you can begin to identify the metrics that will ensure that it will scale. More specifically, instrumenting your app is key. Using debug statements in your code, using diagnostics and role instances, enabling a remote desktop in web and worker roles is a key. Enabling app role and monitoring in the Azure portal is almost I'll say a give me. I mean, it's so easy to do that it's just a free tool in your overall instrumentation package. As you can see in the graph here, there are, I think, a number of approaches and a number of data sources available that include the event logs, the IIS logs, you have failed request logs, performance counters. All these tools can help you understand what's going on with your application. And because to some degree, cloud applications, they feel different. We can't go grab that server. As an example, we can't go downstairs and touch that server. So, we're working at a distance, and having these tools to give you insight into your application is very key. I'm going to spend a little time and chat about the Azure Application Insight service, which is just a fantastic tool that provides you a great deal of leverage into the health monitoring and understanding of what's going on in your application. It's a service within Azure, and it also includes a software development kit that allows you to add hooks into your application, or scripts that allow you to inject scripts into your web pages for logging purposes, which all gets captured back to the Azure portal. So the Application Insight is a great analytic tool. It's extremely easy to leverage. You can turn it on and start getting information in minutes. It's an SDK for development, so it actually can become part of your development process. Again, instrumenting the Application Insight capability into your application. And as well, the Azure Management Portal provides additional tools to enable or disable various features, and to also to view management reports and the various metrics that get reported for your application. So there are a bunch of things that you can get. I've listed a couple of them here. if you're interested in performance and usage analytics for a .NET or a Java application, you're effectively going to integrate the Application Insights SDK into your web app. If you are trying to get additional telemetry on your Azure web app, you can enable insights in the Azure web app in the portal. You can use analytics for web pages, and the way that you can get those analytics from your application. This is, includes, pages, page views, etc., is by inserting a script. Many of you may be familiar with Google Analytics. It's pretty much the same approach in its hook into your application. And you can monitor the availability of your website as well by creating web tests from the portal. And I've got just a couple of views of some of the data that's available. In the left screen that we see a view of dependencies in your application. So we talked before about the retry pattern, and retry being important because of dependencies. So in this particular case, we can see calls to a SQL server, the average response time, the number of times that calls have been made to that service or resource, and some statistics including the standard deviation between requests and response. So this is a great debugging tool. Again, it will give you some insight into how often that retry may actually be saving your app, because some of the dependencies can have large or transient spikes in response time. On the right side, we see some metrics that give you a timeline over a period of page views, including which pages were viewed, the number of times, and the overall percentage. And so these are just some relatively simple examples of how the application insight instrumentation can aid you in moving your application forward, ensuring that it's available, and understanding the health of that particular application. So there are a number of other issues I talked about, code refactoring as another approach to ensuring availability and scalability. This approach, called scale out your application, has to do with the idea that you should scale out and not up. And what that basically means is that in the Azure framework, you can put together a set of resources. So let's just say we developed a cloud service. And so a cloud service has web roles and potentially worker roles. And it's a complex workload where I may have some asynchronous processing. And let's just say that I allow users to upload an image, and then I have a service that takes that upload and creates a number of thumbnails of different sizes, and then stores those thumbnails back in storage, and at the same time updates the SQL Server instance with links to those thumbnails. One way that I can scale out this particular application is by grouping together a set of resources. So that might be, in this example, 3 web roles, 2 worker roles, a queue, which is a sort of a messaging queue, and 2 SQL Server instances. And so when I need to scale out the application, I take those resources as a set and I add 1 more of them. So ultimately I'll have 6 web roles, 4 worker roles, 2 queues, and 4 SQL Server instances. But by looking at scaling out your application in units this way, it becomes easier to duplicate and deploy resources and to understand the process of scaling out. Cloud applications are more prone to network latency and ensuring that content is returned in requests becomes a little bit more important. And there are a couple of things that we can do there in our code. One is that we should consider, and this is not exclusive to cloud applications. You may have seen some of these patterns in, in just what we'll call web applications, but the cloud exacerbates some of these issues by nature of the distribution of resources. So the idea behind chunky, not chatty, is that an application that, say, for example, polls to see if a particular process was completed, so it can, for example, download a resource or a file, as an example, might poll every 10 seconds. Well, if you start adding, a number of users, all of a sudden you start seeing a lot of network traffic and even the potential to even have denial of service in your own application because of the number of users and the chatty approach to the to service calls. A better approach is to have fewer calls, and when a call is successful, as an example, or the resource indicates that the process is complete and there's something to do, that you actually gather more data in that one call, and so the request becomes more chunky, so that you get more, and you have more requests. You have fewer requests that get more data instead of many small requests that get small pieces of data. So chunky versus chatty reduces your overall the number of network calls, and it also contributes to availability and scalability, obviously, because you can have more users that have more requests while those requests are fewer, and they get more data. Caching, I did mention before, but in this particular case, it's caching for data, so that if you have a database in SQL Server as an example in the Azure framework, you can cache the most recent requests, particularly in an application where some of those requests are fairly common. Take an example like a sports team, and everybody wants to know what the schedule is like this week. 5,000 people may come with that same request. That content is best cached because it becomes very responsive, and an actual complete call to the database is not required in order to return that content to the user, making your user interface more responsive, and again allowing more users to utilize your web application, making it more available and again scalable. So in summary, our best practices include a number of key issues. One is that in general, you should favor the Microsoft Azure App Service over cloud service. If, for example, you do find that you have a more complex workload, the cloud service is a great tool. It does require a little bit more work and development, and if you're familiar with using cloud service or developing cloud services in, say, Visual Studio, there is a little more complexity in the overall organization of the solution. So favoring app service over cloud service is a good call, and with the more recent improvements to the app service, again, which was recently renamed from websites, Microsoft has made the service more robust and created an approach to developing applications that will save you a lot of time and give you great leverage with awesome tools with relatively less work. I can't say little work, but less work. So I think favoring app service over cloud service is a great concept. Refactor your code. Generally, you're going to be taking your application, looking into the cloud and saying what features and resources in the Azure framework make sense today and what features may make sense down the road. And as we know in architecture, we tend to like to think a little bit down the road so that we might ease our path to development when we get there. So you should be considering the use of Azure storage for files and resources like video images, PDF files, other images, any kind of blob storage, and definitely moving blob storage out of SQL Server if that has been a pattern that you've used, and move it into Azure storage. Utilizing message queues is a great way to disconnect an application from long-running processes, or to take advantage of fire and forget type processes, or to create what I might call sort of information factories, where a process moves from one stage to the next, and you want to keep track of it, and you have say worker roles that are actually processing when the next stage of processing is ready. Chunky data access is a great key in your, or is a good approach in your service call, in your service layer. And effectively, what you may also be doing there is adding new service operations that may more specifically deal with how the application is using data, more so than perhaps a generalized service layer that provides a fairly general set of operations. Caching is a key both at say the database level and for static content. It moves files away from the compute instance and reduces CPU workloads. And Azure Table Service, which is, I think, to some degree new to most of us in the sense that it's NoSQL. If you've been developing a lot, say, in the Microsoft stack, SQL Server has been your mainstay, and Azure Table Service, being a NoSQL variant, is a little bit new in the sense that it offers the ability to leverage extremely fast lookups with data that is typically denormalized and very unstructured. So it may require a little bit of a learning curve, but it's a great tool, and again, one that is perfect for reference data that may appear in your application and may not actually need to be housed in, say, SQL Server. Instrumenting your code is right up there at the top of a pattern that is really a best practice as you migrate, and to some degree I can't imagine that some of this instrumentation may not be in your code already, but you want to be a little more specific in terms of using the tools that are available in the SDK for Azure, particularly for diagnostic logging, and in particular leveraging Application Insights, which is a great service providing a great deal of leverage with very little work. It's a tremendous tool. secure data communications and protecting your data through encryption and securing connection strings. These are obviously great practices and good best practices. And I think it certainly should give you a little comfort knowing that your data is not out there in the blind, and that you've taken the best steps to protect certain things like your connection strings or very we'll say privileged data from prying eyes and things that can happen over the internet. And then finally here is better, faster, smarter. In the end, as we move more towards the cloud, we develop and integrate best practices into migration and then also into the development of new applications. If your organization is not there, bigger, faster, smarter has everything to do with, one, beginning to automate everything. Everything in the Azure framework can be automated through scripting or the use of the REST API, and that's really important because repeatability is a key to agility. And those things that you do over and over again, you should use every effort to automate. That could be with PowerShell, using the web jobs feature in Azure, or again using the REST API or the SDK to automate a number of tasks, including deployments. Using source control is, I'd say, absolutely necessary. Most of you should be familiar with source control, but source control allows you or a developer to move code into a secure repository. Team Foundation Server is, a very good example of that. And you should also store your automation scripts as well as source control or your application source in a source control repository. And then adopting continuous integration is another concept in this bigger, faster, smarter approach, where continuous integration is when code gets checked into source control. It's down there at the bottom as a source control repository. A build is automatically triggered, and then when you add into that content continuous delivery, you add in that when a successful build and automated unit tests are successfully completed, a build is released. So this allows you to, again, bigger, faster, smarter. And these are all things that Incycle is really good at and can provide you and your organization with the resources and help should you need it. So at this stage, we're ready for questions. I think we moved through the program just a tad faster than I had planned, but if you have any questions, let's take some time to answer them.
Hi, Gregory. A question is coming through. What kind of data do you suggest is external configuration data? Will it just be metadata?
It could be metadata. For example, obviously, say web config or the service config provides an opportunity to move what we'll call basic configuration data into a place that's easy to manage for an instance. But let's say, for example, an application parses a file that may typically have been stored in the file service. Moving that file into say Azure storage and then grabbing that file as needed allows each of the instances to get the same file if it should ever change, and allows you to reconfigure that resource at any time without affecting the existing deployment. So there is the opportunity for metadata and also for data that's actually used in a process. Anything else?
I'm not seeing any other questions come through.
Okay. In the interim, I'm going to turn this over to Stephanie.
Yeah, if you still have some questions, there'll still be a little bit of time, but I just want to talk to you about some really great offers. The first one is an opportunity for an Azure proof of concept, which is up to 5 days and with any workload. And examples of this are dev tests, load testing, performance, etc. And this is a really great opportunity to get creative and try before you buy, and it's 100% funded by Microsoft. And then the second offer I want to talk to you about is Azure Planning Engagement, which varies in duration and is focused on strategic planning and deployment. The outcome is actionable roadmap for your team to execute. This offering is also funded by Microsoft, but only via your software assurance benefits. So we are happy if you have any questions. There is our email at the bottom. Please email us at info@incyclesoftware.com if you need help or have any questions. And then, are there any other questions at this time for Gregory? Okay, I'm not seeing anything. So also, if you have any questions following this webinar, please email us at the info@incyclesoftware.com. And that is all the time we have for today. So thank you again, Gregory, and also to the great folks at Microsoft for supporting this webinar. And then as we conclude, please follow us on Twitter at incyclesoftware.com or on LinkedIn for more upcoming events. And again, I'd like to mention that the Azure Proof of Concept is a limited time offer. So thank you, and we hope you'll join us for our next webinar.